respect to time, then it is called as uniform velocity. That means if you are starting moving from one place, this is the position 1, okay, and at position 2, okay, but traveling from here to here, let your velocity is like 100 kilometer per hour, okay. So this is the second position, okay. From third position P3, here again we like checked your velocity is same 100 kilometer per hour. In fourth position also we take same velocity, which is 100 kilometer per hour. So your velocity is changing here? No, na?
No.
Right? Yes. If it is not changing, that means it remains constant. Okay. So see here we have, this is the first instant, second, third, fourth, fifth, and sixth instant we have. For all the time, velocity is remains same. Okay, 60 kilometer per hour, 60 kilometer per hour for all the points. So we will get straight line, okay, and which is parallel to the x-axis, or we can say which is parallel to the time axis. Then it is called as uniform velocity. Okay. Understood? So by checking the diagram itself, if the graph, okay, the line that we have plot, which is parallel to time axis against velocity, okay, then it is uniform velocity. Understood?
Yes, sir.
Yeah. Okay. Next. Okay, velocity time graph for uniform acceleration. If acceleration is there, that means velocity is changing, whether it may increase or it may decrease. So if it is increases, so we must have that positive slope. Okay, so see here, on first like instant, velocity is 8 meter per second. On second instant, velocity becomes 16 kilometer per second. On third instant, it becomes 24 meter per second. On fourth instant, it becomes 32. So see, each time it is increases by 8, right?
Yes, sir.
Yeah. So it is uniform positive acceleration, you can. Okay, because it gives positive slope. It gives positive slope, right?
Yes, sir.
Yes. So we can draw the graph for the same also, like 0 to 0 on both axis, time as well as velocity. So first point will be here, second, third, and so on, as we like discussed and we did already in last class, right?
Yes, sir.
Yes. You can take a screenshot for the same. No, just take first screenshot for that velocity time graph of uniform velocity. Just take a screenshot, beta. Done?
Yes, sir.
Okay. Now, next. Over here. Second, done?
Yes, sir.
And these are the points.
So can you show it again?
And these are the points. Just take a third screenshot for velocity time graph for uniform acceleration. Done. Now we will discuss equations of motion. So we have three equations of motion, right? First equation we have, it is as V equals to U plus AT. Okay, here V is final velocity. Final velocity. U is what? Initial velocity. A is what? Acceleration. T is what? Time taken. Okay, we will have again S. S is displacement. Okay, so the equation of motion gives relation between all these 5 points. Understood? Understood?
Yes, sir.
Yes. So now we will learn how to derive this equation. So we're going to derive first equation of motion. So I'm writing here derivation for derivation of first equation of motion. Okay. So we know what is the first equation of motion. It is V equals to U plus AT, right? We have to derive that beta. Okay. Okay, everyone, keep replying.
Yes, sir.
Yes, sir.
Yes.
Okay.
Hmm.
So first we tried, we have what do we have? We have acceleration formula. Acceleration formula. What is acceleration formula? It is A equal yes,
V.
A equals to V minus U divided by T, right?
Yes,
Yes.
sir.
Change in velocity divided by time. Change in velocity divided by time. Okay, this is nothing but the acceleration. Okay. So I'm
Aros,
just
reduce the audio.
who beta? Okay, so I'm just transferring that T to other side. So as a transfer of rule, we know if it is in denominator, if you will transfer to other side, it will go to numerator, right? So what we will get?
Yes, sir.
V minus U equals to 80, right?
Yeah.
Yeah. Now I'm going to transfer that negative U to other side. Okay. So, and we know according to the rule of transfer, negative becomes positive, right? So it will become V equals to U plus 80, right? And this is nothing but our first equation. You can check, right?
Yes, sir.
Yes, sir.
So it's easy or quite easy?
So it's easy.
Yes. Wait a second, beta. I'm just wait. Yes, yes, it is correct. Just write it down.
Done.
Okay.
Done, sir.
Okay. Any doubt here?
No, sir.
Okay. Okay, so now we will learn the second equation of motion. Okay.
Yes.
Okay.
Yes, sir.
So derivation of second equation of motion. So anyone have any idea what is the second equation of motion?
No, sir.
No, sir.
I have written already now. I have written already beta over here. Where? Wait. It is as equals to u t plus half of 80 square. No. I wrote only one. Sorry. Okay. Now
What
we
did you
gonna
ask, sir?
what is the second equation of motion? S equals to ut plus half of 80 square. Okay.
Sir, can you repeat the question? I didn't understand.
What is the second equation of motion? I asked that.
Second equation of motion, sir.
Yeah.
What is it, sir?
We gonna understand. See, this is the first equation of motion. V equals to u plus 80. Okay. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
So
Okay.
this is the first equation of motion. Now we're gonna discuss second equations of motion. How to derive that.
Sir, like what are these equations of motion used for?
Suppose if you want to calculate acceleration, so you have to use that.
Okay.
Yes.
Sir, for finding acceleration, we have to use change in velocity by time, time, right?
See, here we have first equation we just derived. It is V equals to U plus 80, right?
Yes, sir. This is for
So
motion.
if, if here we have V is what? Final velocity. Final velocity. U is what? U equals to initial velocity,
Initial
right?
velocity.
Yes. Then A is what? Acceleration. T is what? Time taken. Right? Yes. So if
Yes,
you
sir.
can, if only any three values are given, so you can calculate the fourth one. Any three are given, so you can calculate fourth one, right? Is
Yes,
it or
sir.
not?
Yes,
Yes.
sir.
Yes. Okay, so these are like used in order to calculate either final velocity or initial velocity or acceleration or time taken. Now by using second equation we can calculate distance also. Okay, so we have second equation of motion. I'm going to write here first. Second equation of motion is
Sir, is velocity and speed the same thing?
velocity and speed. If both are taking place in a same direction, in a straight line path, then yes, both are same. But if path is not straight, so they are different.
Okay, sir.
Okay. Yes. Now any doubt?
No, sir.
No, sir.
No, sir.
Okay. So we'll move further then.
Yes, sir.
Okay.
Yes.
Now we will discuss second equation of motion. So second equation of motion is, it is S equals to ut plus half of 80 square. That we had to derive. Okay. Here S is what?
Speed.
Displacement.
Displacement.
Okay. U is what? We already discussed. Initial velocity. Initial
Velocity.
Velocity. You have the derivation in your syllabus, na, or no?
I don't think so,
Sir, we
sir.
don't have it, sir. This
Okay,
second.
so you can just do remember like all the three equations only. Okay, so I'm going to write this is the first equation. Sorry, the second equation. Third, I'm going to write here. Third. Third is we have v square equals to u square plus 2as. And first equation. First equation is we just derived v equals to u plus 80. Okay, so these are the three equations you had to remember always. Okay, because it may ask to solve numericals based on that. Okay, so I want you had to check your like syllabus. What is like left there in this chapter? Huh?
Just a second.
Yes.
Well, we have this.
Huh?
Yes, sir, we have this in our textbook.
You have, na?
Yes, sir, we have this.
Yes. So you must be having numerical based on that.
Yes, sir, we have.
Yes. Okay, that's why these formulas becomes very important. Okay, so they are equations of motion. Okay, they are
Yes. So then can you explain the second one? We stopped at the second one.
equations of motion. Okay. See, if you have beta, see if you want to calculate displacement, x is what displacement, right? So for that you must have initial velocity and the time plus you have to add like half of 80 square. So here u is initial velocity, okay,
Initial.
c
Yes,
is time taken, okay, maybe initial velocity is 0, maybe 0 also sometime, okay, then a is acceleration, okay, and s is beta displacement.
Okay, sir.
So we have like 5 variables here. If out of this any 4 you have, you can calculate the first like distance, whatever you can like derive. If you have 4 variables known, so you can calculate fifth one. It may be time, it may be displacement, it may be like displacement means nothing but the distance only in a straight line path. It may be you can calculate initial velocity also, or maybe acceleration or displacement, whatever. Okay, depend on the question what is given there. Okay. Okay.
Yes, sir.
Yes, sir.
Okay. Any more doubt now?
No, sir.
Oh. Okay. Now what is next beta there? In your textbook.
The
Sir, we have uniform circular motion.
Huh?
Uniform circular motion after that.
Okay. So circular motion and okay, circular motion where? Okay. So we'll discuss circular motion. Circular motion and then uniform circular. Yeah.
Okay, sir.
So we have rate of change of velocity also.
Rate of change of velocity is nothing but acceleration beta.
Okay. Oh, yes, sir. Yes, sir.
Okay. Okay, circular motion. See, so I have to draw first the circular path here. Okay. Okay, so this is the circular path, beta, right? Right?
Yes, sir.
Yes.
Beta, let me make little change. Wait. Sometimes no, it's not working when I used to take shape. Yeah. Suppose this is the circular path beta. Okay. Okay, so here we have center of the circular path. This is center, right? Is it or not?
Yes, sir.
Yes, sir.
If suppose, and this is a circular path.
Yes, sir.
Circular path. If suppose object is moving along with the circle, then it is called a circular motion.
Okay, sir.
Someone is beta. Wait a second. Okay, is screen visible clearly now?
Yes, sir.
See,
Yes, sir.
circular motion means if object moves along with the circular path. Okay, circular path means it must have the circumference and the center, right? Is it?
Yes, sir. Yes.
So if any object is moving along with the circular path, that means it is a circular motion because it is changing position, na? Right? It is changing position.
Yes.
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 But yeah, the same thing here. If we have to apply, if the object moves along with circular path and travels equal distance in equal interval of time, then it is called as uniform circular motion.
Okay, sir.
Done. Very easy. Okay, now I have some questions. Have you wrote everything?
Yes, sir.
from the screen? Okay. Now I have one question. If suppose object moves from here, okay, here, and again it moves like total circular path and reaches over there only. So initial and final point will be the same, right?
Yes, sir.
So
Velocity.
in that case, not velocity. In that case, displacement may be zero, beta.
Sir, it will be 0, right?
Yeah,
Yes,
but
sir,
if
because
it
it's
is,
coming at starting point only.
but suppose if it is moving from here and stop over here, then okay, suppose object start from moving from here and stop here, then it is not zero now. Is it or not?
Sir,
Yes,
if
sir,
we
it's not
stop in the
0.
middle, then the displacement changes.
Yeah, so maximum displacement in circular path is equals to maximum displacement I'm discussing is equals to the diameter of the circular path. It will be the maximum displacement, right? And minimum displacement may be zero. Means there is no displacement. Okay, and suppose if you want to like calculate what distance. So distance, what is the circumference of the circle? Formula 2 pi r, na?
Yes, sir.
Yes. Okay. So it is 2 pi r. Wait a second. Let me write here. Okay. Here we have 2 pi r. Pi formula. I'm writing pi. Okay. Pi means pi and r. What is r? R is the radius and pi is 22 divided by 7. Right?
Yes, sir.
Is it or not? Yes. So by which you can calculate the distance. So 2 pi r is the formula that we have to use. Okay. What is the value of 2 pi r? It is 22 divided by 7. So if you will solve, you will get 3.14. How will you get? Pi equals to how much? 3.14.
Yes.
Understood? Yeah.
Yes.
So this is the value for pi. Okay. 3.14592 and that much. Okay. But what if 2 multiply by 3.14? How much you will get? It is 6.28, right?
Sir, 28, 0 to 18.
Oh yeah, 28. Okay, so 6.28 into radius, okay, will be the distance traveled by the object, right?
Yes, sir.
So finally, you can say distance traveled by the object, okay, along with the circular path is equal to the circumference, and which is equals to 6.28 into radius. Into generally radius is represented by small r beta. Okay, I have written a capital R, but generally it is small r, like this. 2 pi r. Easy.
Yes, sir.
But here initial and final point may be same. So displacement may be zero. Okay, displacement may be zero. Understood?
Yes.
Yes, sir.
So now any doubt here in circular motion?
No, sir.
Okay. So just write it down. Along with circular path, okay, displacement may be zero. What's the condition for that? When initial and final point are same. Understood, beta?
Yes, sir.
Yeah.
Good. So take a screenshot then. Okay. So very important point I'm going to write here now.
Just a second.
So make down.
Just a second, Sam.
Yeah. Diameter. And diameter is represented by d, and d equals to twice of radius. Okay.
Okay, sir.
Now any doubt here?
No, sir.
Okay. Okay, what we have next, do check. Yes.
Yes, sir. So 1 second, can you show the point again? The last point that you have told.
Yes.
Yeah, thank you, sir.
Any doubt now?
No, sir.
Okay. Okay, we have 9 minutes left. Okay, one have quizzes then.